Good morning, everyone. I'm Sarita Swanepoel, and today we look at mole calculations. Now, what is a mole? A mole is just a counting number. It's like a dozen. Where a dozen is 12 eggs, when you look at one mole, that is 6,02 times 10 to the 23 particles. So that's a lot of particles, but we're working with very small objects. If you look at one pinprick, that's already a lot of atoms or molecules. So we need a big number. How many is 1 mole? Now it was decided to take 12 grams of carbon-12. Now why carbon-12? Well, we can also find carbon-13, but carbon-13's got one extra neutron, and that makes it heavier. So we're only going to look at carbon-12, and we're going to use 12 grams of that. And when you determine the number of carbon atoms in that 12 grams, then you find that is Avogadro's number. That is 6,02 times 10 to the 23rd. So in 1 mole, that is how many particles. And we decided that by taking 12 grams of carbon-12 and determining the number of carbon atoms. Now you've got a few different options. When you want to work out the number of moles, you can either work with N equals M over M when they provide you with the mass. And remember that molar mass down there, that is the mass of 1 mole of that substance. And you can get that from the periodic table and just adding the relative atomic masses of all the different atoms in that compound. And then we move on to the next one. Now here we're working with particles. When we work with particles, that particles can be ions, atoms, molecules. You just need to know how that substance occurs in nature. And here you're going to use the number of particles divided by Avogadro's number, that's 6,02 times 10 to the 23. When you have volume, you have to be careful. There can be volume for gases when you use this equation, and you can also have a solution volume, and then we're working with that one. Now when you have gas, you are going to work this as equation, and the Vm down there is now the volume for 1 mole. And it doesn't matter if it's oxygen, hydrogen, nitrogen. When we are at standard temperature and pressure, then all gases will have a volume of 22,4 cube decimeters. And that's what we're going to use in there. Here you have to know that the volume must be in cubed decimeters. And whenever they give you volume in cubed centimeters, you are going to convert that to cubed decimeters. We can do that by dividing by 1,000 or multiplying by 10 to the minus 3, which is the same thing. So now we're going to look at solutions. The concentration of a solution is measured in moles per cube decimeter. So here we're going to use this equation, or you can even substitute that N in there with N equals M over M, and then you end up with this new equation, which is also on your information sheet. And it's actually very easy to use and keep you from doing 2 separate calculations. Now, once again, remember that volume must be in cubed decimeters. Now, let's look at the first question. In the first question, they're asking us for the number of water molecules. So they are asking us for the big M that we use for the number of particles. They gave us the mole. For that, we've got N, and then you know it's water. Now, the only equation that's going to help you with that is N divided by Na. And then you just have to substitute. In number 2, they ask us for volume. Now watch out for volume. Remember, you've got volume there with the gas, and you've also got volume there with solutions. Now read the rest of the question. They're asking us for volume, but they give us mole, and it is a gas, and it is at standard temperature and pressure. So immediately we're going to work with that equation. And then it's just a question of substitution. And remember that 22.4, it's only true because we are at standard temperature and pressure. And then you have to remember the final answer must be in cubed decimeters. In number 3, they ask us to calculate the number of moles. So we are looking for small n. And they're giving us ammonia. So already we have big M we can work out because we've got ammonia, and then they're giving us mass. So the equation I'm going to use is N equals M over M, and first we have to calculate that molar mass there at the bottom, and that is for ammonia. So you go to the periodic table and you work out that molar mass, and then we can use it to substitute into our equation. Now that last question, they ask us to calculate the mass. So we are looking for small m, and they tell us we're working with silver nitrate. That's going to give us the molar mass, and they're giving us the volume over there and also the concentration. So immediately I know the equation I'm going to use is C equals M over big M times V. Substituting in there, I need that molar mass for silver nitrate. Now guys, you need to revise your table of ions because you need to be able to write the formula of any compound that they give you. So here, silver nitrate, you have to know is AgNO3. Silver is 1 plus and nitrate is 1 minus, and they will combine to give you silver nitrate, and then you can work out the molar mass. And then the rest is just substitution. On the next page, there's a lot of questions for you to do just to make sure that you are comfortable with this before we move on to stoichiometry in the next video. So pause the video and come back as soon as you've finished. In number A, you have 300 cube centimeters, so they're giving you a volume and they're telling you it's a solution. So the equation you're going to work with is C equals M over M times V, and then they give you mass, they give you volume, and the only thing you need is the molar mass for sodium chloride, and that you calculate from the periodic table. And then you end up with 5,70 moles per cube decimeter. Remember, that is the unit for concentration. In number B, they ask you how many moles, so you're looking for small n, and they're giving you a number of particles. That's going to tell you we are going to work with N equals N over Na, and then just substituting there will give you 15 moles. In C, they ask you how many mole of CO2 gas are there in 4,48 cube decimeters at standard temperature and pressure. So there they give you a volume, and it is a gas, and it is at standard temperature and pressure. So this was easy. You used N equals V over Vm and just substitute it in there. Right, in number D, they ask you what volume, and they go on and they tell you it's a gas at standard temperature and pressure. So it's again that N equals V over Vm, and you are just going to substitute in there. And remember, the final unit must be cubed decimeters, because always in chemistry you need that. In number E, they ask you what is the mass, so we're looking for small m, of 0,6 moles, so they're giving you N, and they're telling you they're working with potassium sulfate. You need to know that there's 2 potassium ions bonded to 1 sulfate so that you can work out that molar mass. And then it's an easy substitution into N equals M over M, and you end up with 66,40 grams. Remember, chemistry, grams, not kilograms. In number F, they ask you how many molecules. So they're asking you for particles. So we're looking for big N, and they give you mole, and that makes it easy to see you are working with N equals N over Na, and it is just a plain substitution. In number G, they ask you to calculate the mass. So we're looking for small m, and they tell you it is in a 200 cube centimeters, and it's standard temperature and pressure. It's a gas. Now we've got a problem. They're giving us volume and they're asking for mass, and you don't have a single equation with both of them in. So let's start with what they gave us. They gave us the volume of a gas at standard temperature and pressure. So first off, I will use N equals V over Vm and substitute to get the moles, the number of moles. And then we will use that in our mass equation and then just work out the mass of the hydrogen chloride gas. Number H, calculate the mass. Once again, they're asking for mass, they give us volume, but this time it's not a gas, it's a solution. So I need to work with C equals M over mv, and important, how do I get big M? I'm working with sodium carbonate. So that big M, I'm going to have to write the formula first. 2 sodium ions, plus and plus, to bond to a carbonate ion that is 2 minus. So give you 106 grams per mole, and then it was just a question of substituting. In number I, they ask you for volume, and I'm just going to check, it's a solution, it's not a gas. They're asking you for volume, they're giving you concentration, and they're also giving you mass. Now, for this one, you have a combined equation that works fast and neat. You don't have to do C equals N over V and then N equals mass over molar mass, but that would have been totally acceptable and would have given you all the marks. Now, since we have a molar mass over there, I need to work with hydrochloric acid. So first off, let's just calculate that molar mass, and then you put that into the equation, and it is an easy substitution, and the unit cubed decimeters. In the next one, they're asking you how many ammonia molecules are there in 33,6 cubic decimeters of gas at standard temperature and pressure. Now, if you've got standard temperature and pressure and it's a gas and you've got a volume, then first off, I'm definitely going to work out the moles from that. And once you've got the moles, then we can work out the number of molecules, the number of particles with N over Na. In number K, they asked us for mass and they gave us a volume, and it was a gas. I've got a volume of a gas at standard temperature and pressure, so I'm going to use N equals V over Vm to work out the number of moles, and then you can use that in an equation. And guys, remember, you need 2 places after the comma. So start practicing now that you really have that correct, because that is the instructions in the final matric exam. In number L, they ask us to calculate the volume occupied by 100 grams of oxygen gas. Now, volume and gas, I'm definitely going to use that N equals V over Vm somewhere, but I'm starting out with mass, and it's oxygen gas. Now, first off, there's something you need to remember about oxygen gas. Oxygen gas is a diatomic molecule, which means it occurs as O2. So if you work out the molar mass, you need to work out the molar mass for O2, and then you can use that first to calculate the number of moles using that 100 grams, and then using that to get the volume. And since we with a gas and it is at standard temperature and pressure, and it is definitely at standard temperature and pressure, you get a volume of 70. And remember that 2 places after the comma, and then the unit cube decimeters. Right guys, I hope you've got this 100% correct, because in the next video we're going to use that to go on to stoichiometry.